So this is our second installment of the optimization problems. We've got a couple different problems here. They're fairly similar, but slightly different. So this says, the first question says, Farmer Charlie is going to make a pen for his bull Ferdinand. He has 2,400 feet of fence and would like to make the largest possible pen for Ferdinand. In an effort to maximize the pen area, he'll be using a river as one boundary for the pen. What are the dimensions of the pen with the largest possible area? So probably would be helpful to draw a little picture here. Let's start by just saying here's a river. River. And it says we're going to make a pen for his bull Ferdinand. So Ferdinand is going to be enclosed in this rectangular pen. It doesn't say rectangular, so I guess you could technically do a circle or something, but I should have said rectangular pen. And we want to figure out what is the largest possible pen that we could make for this bull. So what we're going to do is we're going to add some letters to this to help us out. We're going to call this X and this X, and then we'll call that other side Y. And the river side is also going to be Y, but we don't need fencing for that. The green stuff is all we need fencing for. So what we're dealing with here is we're dealing with two different equations, really. We're dealing with a fence equation, which I'm going to say is F. The fence equation is going to be 2x plus y. That's how much fence we're going to use, because we have an x on top, an x on bottom, and a y on the side. So it's 2x plus y for the fence. The other equation we're going to be dealing with is area. Let's see, area. The area of this pen is just going to be x times y. Okay, so what do we know? We know that he has 2,400 feet of fence and would like to make the largest possible pen. So what we know is how much fence he has. I'm just going to replace that F with 2,400. So maybe I should do an arrow, not an equal sign. Equals 2x plus y. So if I want to type this into my calculator, I'm going to need to get just one equation to work with. So what I'm going to do is I'm going to solve this equation just for y. So I'm going to subtract 2x from both sides, and I get 2,400 minus 2x equals y. And so I know that this stuff will equal y. Then I can plug it into the area formula to find the maximum possible area. So the area is going to equal x times, and then this stuff we just figured out, 2,400 minus. So this is what I'm going to type into my calculator. So I'm going to use decimals to help me out with this. And I already plugged it into Desmos, but now I'm realizing that I plugged it in incorrectly. I put 2,400 minus x divided by 2. I have my equation slightly off here. So it was 2,400 minus 2x, if I recall correctly. Yep, 2,400 minus 2x times x. Let's go back to Desmos. I'm going to have to do a little bit of zooming to figure out where this thing is. All right, so it looks like here's my graph. And there is our maximum. We have two X-intercepts, and we have a maximum. Now let's talk about these X-intercepts for a second. This first one that says 0, 0, that means that if your X value is 0, that means that, go back to our picture here, this X portion is 0 long, you would have an area of 0. And that should make sense. If we don't make that X portion any width at all, you're not going to have any area. If the X portion, the other X-intercept, is 1,200 comma 0, and that's saying if I make X 1,200, we'd have 1200 on top, 1200 on bottom. That's going to equal 2400. So that means the y value would end up being nothing, so you'd have no area as well. So that's what those two x-intercepts mean. But what we're mostly concerned with is the maximum. And this tells us when x is 600, y is going to be 720,000. So the maximum is going to be when x equals 600, y, but it's not y because this equation is for area. So it's actually area equals 720,000. Am I remembering that correctly? Yep, 720,000. So what this is telling me is if this pen is 600 feet wide, then that means the area is going to be 720,000 square feet. Then to figure out the y value, let's see, yellow here. To figure out this y value right here, well, we have 600 and 600, that's 1200. And the total amount of fence is 2400, so 2400 minus 1200 is 1200. So the dimensions, the question asks you for the dimensions of the pen. Dimensions are, let's say dims are 600 feet by 1200 feet. And the maximum possible area would be 720,000 square feet. Okay, let's look at one more example here. It says, Farmer Charlie now needs to create a pen for his chickens. The chickens need 200 square feet for their grazing area. What is the minimum amount of fencing needed to create a pen of 200 square feet? What are the dimensions of that pen? So it's a pretty similar question to the last one. Here's our rectangular pen for our chickens. And they're going to be grazing inside here. There's all my little chickens. And they're radioactive, I guess. And so the sides we're going to call X and Y. So we have a rectangular pen again. There's going to be a fence equation. And this time there's no river binding it on one side. So the fence is going to be 2x plus 2y. And the area of this is going to be just x times y. Okay, so what do we know? It says the chickens need 200 square feet for their grazing area. So area, and maybe area, that's not the same area as what we're talking about in terms of area of square feet, but it does say 200 square feet. So that's going to be what the area of this pen is. And we want to find the minimum amount of fencing. So what I can do is I can say that if I want to solve this one for, let's say, for y, I'm going to divide by x on both sides, and I get y equals 200 divided by x. So I'm going to go back up here into the fence equation, and I'm going to replace that y with 200 divided by x. So the fence equation is now going to be f equals 2x plus 2 times 200 divided by x. And so now I have an equation for the fencing. I can plug that in my calculator, and I want to find a minimum. So it's going to look something like this, and I want to find a minimum in that equation. All right, let's do that. Let's head over to Desmos. I already have it typed in, just like a cooking show. I have the final product ready for us here. This time I did type it in correctly. It's 2 times 200 over x plus 2x. And of course I messed that up already. Here we go. So we have kind of a funky looking graph, but all I'm really concerned about is the stuff in quadrant 1, because the stuff in quadrant 4 is really not going to be possible. We don't want negative x values for our pen. That doesn't make any sense. So we're going to stay up here in quadrant 1. And it looks like our minimum is at 14.14 and 15.57. So 14.14, comma What did I say that was? I already forgot. 56.57. So this is our X value, and the Y value represents fencing. So that means that the minimum amount of fencing would be 56.57, and the X side of this would be 14.14. Okay, so if it tells us that the area is 200, we know one of the sides is 14.14. And I know like the area formula is X times Y. I can plug in what I know and figure out what the missing side is. So 200 equals 14.14 times Y, divided by 14.14 on both sides. And I get Y equals, let's swing over to Desmos, 200 divided by 14.14, and it's 14.14. So no surprise here, the maximum area of this rectangle would end up being a square. Okay, so our dimensions are 14.14 by 14.14, and the maximum or the minimum amount of fencing to do that 200 square foot area is 56.57 feet of fence. All right, so those are a couple of optimization examples for you dealing with like fencing around a perimeter.